So with the calculator now, I'm going to punch that log of 5/2, and I'm dividing the logarithm by a logarithm. Dividing by another log of 50. And I'm going to store this in memory cell. I hit the store key, which is down next to the on key, just above the on key. And so then I'm going to store this in memory cell alpha. See the cursor here is now in alphabet mode using the alpha key, and I'm going to pick the letter A for answer. Okay, so there's our answer, 0.2342. 0.2342 for x, approximately. And here's the exact answer here, and the approximate answer next to it. Exact and approximate. Now, the way we check it, I had stored that answer in memory cell A. So what I do then is I come back to the original problem and I check to see if the left side equals the right side. And I could do that right here. 2 raised to the 0.2342 plus 1, is that equal to the right side, 5 raised to the 1 minus 2 times our 0.2342 value. Sorry for getting messy up there. Now I'll do that on the calculator. 2 raised to the alpha A plus 1. Here's that value. And then I'm going to take the other side, 5 raised to the 1 minus 2 times alpha A. Something looks fishy.
Yeah, it was. You took 5 and raised it to and multiplied it.
Oh, thank you. You see how you should be disturbed at this point if you don't get the left side of your equation's value equaling the right side. And as Todd noticed, I forgot to put my exponent key in right here. Okay.
It does equal.
So I will replay that. I replay the expression by going Shift and then hit my Enter key, brings back that past expression. I come back in here and I go to Insert mode, which is on your delete key. Insert an exponent, and now you can see that 5 raised to that power is equal to the 2 raised to that power.
Where did you say the insert key is?
On your delete key right next to the blue arrows. Very handy. So you can go into
If you want to use your arrow keys, you have to use the green alpha button and then push the arrow.
the blue arrow keys or the store key.
This,
Oh no, you can just start moving around.
it doesn't. It'll go to the beginning of that specific sentence, but it won't go up on the page.
Oh,
It's
no,
still
no,
on
you
the
can't
page.
go up on the page. Oh, what I did is I used what's called entry down on your enter key. You have to, if you want to go back through your memory, here's something some of you may not be aware of. I can go back through the memory, watch this, by Shift, hit the second, enter, watch this. I can just go back through the memory from earlier work. See? Things from last week even, okay? And then
it'll go back forever.
eventually, see, I got back to, it's a stack. It's a stack of items that are back there in the memory of the calculator. And so I can work my way back through that
And
memory.
it doesn't go back all the way to when you bought your computer.
No, not at all. It's a short
Just a
loop.
little way.
Okay, let's do some more problems today. We started this equation, this was an exponential equation. Earlier, we had a logarithm equation. Okay? So those are the techniques that you use for solving both styles of equations by these examples. And always check your answers. Okay? Let's do something that's an application. And we did an air pressure application in the last session, but let's do something else. Let's say that we knew how much time it took something to double. Maybe it's the amount of bacteria. Maybe you're in a biology course and you have a petri dish and you put some bacteria in there. Have anybody taken biology where you've done that? Okay, several of you have. And then you look at a microscope a certain amount of time later and you can sort of see how they've multiplied. Okay, as long as there's a food source there for the bacteria to grow. So let's say we know a doubling time, how long it takes the population to double. Somebody give me an amount of time.
1 second.
Oh, that's boring. 1 second's boring. Something more exciting.
13 hours.
13 hours. 13 hours to double. Okay, so what I want to think of is we have a doubling time equals 13 hours. So I'm going to graphically think about this. So here's time in hours, and this is the number of bacteria. Okay, number of bacteria. So let's say we start out with this many bacteria. How many?
Billion.
A billion. 10 to the 9th bacteria. A million, 1,000 million. A billion bacteria. Okay, and we know that it takes 13 hours for that population to double. That's roughly double, right? So that point right there is 13 comma 2 times 10 to the 9th. Okay? We start out with 10 to the 9th, and it's doubled in 13 hours. So now, what's the shape of the graph? Is it a straight line? Not for exponential growth. It's a curve that gradually gets steeper and steeper and steeper. How much time will it take to double again from 2 billion to 4 billion?
13 hours.
Another 13 hours. And that would then be a quadrupling time, wouldn't it? If you get out here to 26 hours, you're going to be up at 4 billion. Okay. So doubling times are amount of time for a population to double. This could be money. In this case, it's bacteria. Let's build a model now that will represent this. So the amount of bacteria, let's call it B, the number of bacteria is equal to, we want to build ourselves an exponential model. What's the y-intercept?
1 billion.
The y-intercept, 10 to the 9th, okay? So we have that many to get started, okay? Times, now there's several ways we can play with this. If I use the base 2, and an exponent, say, of t representing time, that's not going to work. Because what if I put a 1 in here? 2 to the 1, that would give me 2 billion. But it didn't take 1 hour, did it? It did not take 1 hour.
13.
It took 13 hours to double. So how could I I know the doubling time is 13. So I want the exponent up here, I want this exponent to be 13. I want it to be a 1.
13.
So if I took the number of hours divided by that 13, If I put 13 in for t, then I get an exponent of 1. Follow that? If I put a 13 in there, I can force this exponent to become a 1 using a base of 2, and that's going to show my doubling time. Like that? Okay. This is one way of doing this if you had a piece of information about doubling time. In the next class session, I'm going to show you another way to do it. So here's a model. Now watch this. 10 to the 9th is just a number, a billion. And then we have 2 to the 1/13th power raised to the t. Let's punch 2 to the 1/13th. It's going to be bigger than 1. What do you get?
1.05.
Okay. So this is approximately equal to 10 to the 9th times 1.0. Let me get it to 4 decimal places.
Okay, 0.548.
Okay. So there's our model. There's our model. Let's check it with a calculator. We have about 2 minutes or so left, I believe. Okay. So what we do is we come into our calculator now, and let's go to y equals, and I'm going to use my power of 10 key, 10 to the 9th for my initial population, and I'm going to multiply this times 2 to the 1/13th power. And look at the way I punch that. And I need to insert a parentheses up there in that exponent, folks. So watch this. I'm going to insert, just to add clarity, I'm going to insert a multiplication symbol there. And right up here, I'm going to insert a parentheses to make sure that exponent on 2 stays 13's reciprocal times x. Now I need to quickly build a viewing window. So let's go to 30 hours and put tick marks every, 0 to 30 hours, put tick marks every 13, which we know is our doubling time. And let's put the bottom of the screen at negative 10 to the 9th. And let's put the top of the screen at 3 times 10 to the 9th, and put tick marks every 10 to the 9th. Okay, so there's our window settings, and we hit graph, and we should see exponential growth, and we should see, since I wrote doubling time here as 13, you should see this value is twice, okay, right there. And so let's check it out at trace at 13 hours, and you can see it's right on our 2 times 10 to the 9th. In scientific notation down here, folks, 2 times 10 to the 9th. Okay? So this is how you can take a piece of data, a piece of information, and build yourself an exponential model and force it through the points. What we'll do in the next session is we'll learn how to make the bases different, like base E or some other type of base, and we'll work on some other applications. Okay? We'll see you all next session.